I'm muted. Am I muted?
No.
Oh. All right, I'll mute myself now so that when you go on, we're good.
Okay, great.
Thanks.
All right, hello everyone. We are going to start in a minute. We're going to give people a couple minutes so that they have the chance to log in. But feel free to use the chat box to say hello and introduce yourself. All right, well, welcome everybody. This is Lauren Oglesby. I'm the Content Communication and Programs Coordinator at AIA New Orleans. And we'd like to thank you for joining us today for this webinar. This webinar is presented by one of our professional affiliate members, Hahn Industries. And today, on behalf of Hahn, we're going to hear from Richard Lubbers, who is joining us from Icon Shelter Systems. Just a heads up about the format. Everyone on the participant end is going to be muted, but you will be able to ask questions. That'll be either through the Q&A box or the chat box at the bottom of your Zoom window. So be sure to type in your questions there and we will address them at the end of the presentation. And please don't use the raise your hand function. It doesn't quite work that well. And now we won't be recording this webinar, but if you miss any part of it or if you love it and you want to share with people, there's an on-demand version of this training which is available on AEC Daily, and we will be linking to it on our website. So look for that. We are a two-person team and we really don't have the capacity to handle IT issues on your end while we're conducting the webinar. So as a backup, if you run into any issues, you can call in with the number that was just sent to your email. And lastly, if you do decide to call in on your phone, we can't see your name on the registration sheet, so please email your name and AIA number to me, Lauren at aianeworleans.org for credit. If you're logged in via computer or via the Zoom app on your phone, you can disregard that because we do see your name pop up. Okay, on the agenda for today, we're going to hear from Richard Lubbers. And then following that, we'll have a Q&A session using your typed comments and concerns. And we're going to close out by highlighting some of our upcoming webinars and some other resources that we've put together for you. I'll go ahead and introduce Richard now. Let's see. Richard is the Vice President Marketing and Design at Icon Shelter Systems. He started working in the pre-engineered manufactured shelter industry in 1988. He worked for 2 other companies before starting Icon with several other former coworkers in 2004. Over the years, he's produced dozens of designs that helped to redefine the pre-engineered shelter landscape. In 1990, he introduced the first multi-tiered steel frame shelter in the industry. And eventually, variations of that design concept appeared in bid documents prepared by design professionals throughout the United States and Canada. Thank you so much for being with us, Richard.
Well, thank you for having me, Lauren, and hello to all of you. We are glad that you chose to join us today. This is an hour and 15-minute presentation. It's 1.25 credits, but I try to talk fast and we can get through it in an hour and give you some time to ask some questions if you have to do that. So with that, I'm going to share my screen and we will get into the presentation. You should see a picture of a shelter with the sun going very low.
Yep, looks good.
And I'm going to turn it into slideshow mode, and away we go. Outdoor shelters not only provide protection from the elements, but also add visual interest to outdoor public spaces. And advances in shelter design are changing the way the recreational landscape is defined. This course looks at current capabilities in shelter design, compares pre-engineered to site-built shelters, and focuses on the advantages of using a manufacturer who offers design and engineering services. Sustainable aspects of shelter design are also discussed. The learning objectives are, at the end of the program, you will be able to identify industry standard shelters and describe new trend-setting shelter designs that are meeting a variety of functional and recreational needs, protecting people from environmental elements while supporting social activities. And of course, these days, that's a little different. You'll be able to compare pre-engineered shelters to site-built shelters in terms of architectural design, engineering, manufacturing, and installation. You'll know how to work with a pre-engineered shelter manufacturer to design and specify a shelter that meets local building codes and design loads, is durable, and is aesthetically pleasing. And you'll be able to explain how shelters can help meet sustainable design goals and contribute to LEED credits by reducing exposure to environmental tobacco smoke, by minimizing effects on human and wildlife habitats by reducing heat islands, and through the efficient selection and use of materials and resources. So we're going to look at some types of shelters. A well-designed shelter can be a focal point in an outdoor space, providing a safe, comfortable, and shaded area for the community to gather. Be it a park or playground, athletic field or golf course, or an outdoor market or restaurant, there are shelter solutions available to meet the design and functional goals of the project. And here you can see a lot of the standard type of shelters that you'll find throughout the market, made by all of the different shelter manufacturers. Industry standard shelters, as I just showed you, traditional shelters and gazebos grace outdoor spaces across the country. Most shelter manufacturers offer variations of these common shelter types in an array of sizes and materials and a range of prices. But then there are other types of shelters that our company's been working with, and some of the others as well. And these are more cutting edge. While common off-the-shelf standard shelters fit the plan for most recreational settings, innovative ideas, some of which are pictured, have been introduced and are creating trends in park design. Dual pitch shelter has two sloped roof surfaces. A gable roof is a simple dual pitch shelter in that it has two sloped surfaces that create a peak. Other dual pitched roofs are structures where there are two different pitches in a slope or two opposing monoslopes at different roof pitches. According to the Dictionary of Architecture and Construction by McGraw-Hill, 1993, a clerestory is defined as an upper zone of wall pierced with windows that emit light to the center of a lofty room. Clerestory shelters are a variation of that concept in that they have two roof tiers with a sizable space between them that allows light into the center of the structure. These are much like barns and manufacturing buildings that were built with a monitor roof, which is shown at right. A pergola is a garden structure with an open framed roof supported by regularly spaced columns. The definition has broadened to include any structure with a slatted, latticed, or otherwise partially open roof, which also includes garden arbors. They started being produced by the pre-engineered steel shelter companies in the 1990s and are available in steel or wood or combinations of both. They can be fitted with fabric canopies to block or diffuse the overhead sunlight. Living roof shelters combine a green roof product with a steel structure to create a cool and attractive shade space. An engineered roof fascia is designed to work with a modern green roof system. Structures can be fitted with irrigation to keep the green roof healthy and lush. Flexible water lines can be fed through the steel framing members to the peak of the structure. At the roof, burying the water lines in the soil avoids unsightly lines in young plant trays and reduces the opportunity for vandalism on the system. Drainage is designed into the fascia system and can be taken to grade with a gutter and downspout. Structures don't always have to be only provide shelter, but as seen here, they can provide a view as well. Elevated platform shelters provide another level of usable space, serving as multifunctional structures. They can be fitted with lights, outlets, tables, and seating, and other amenities. Arches, gates, and other types of structures serve as entrances to parks. Most entry portals have some type of signage or graphic identifying the site. They are available in many shapes and sizes, ranging from the width of a single pathway to the span of a roadway. Tubular steel has dominated the steel shelter market for over 30 years. New designs utilizing I-beams with rivet plates, heavy wood rafters, and rod on clevis create a retro industrial look. Large laminated wood beams fit well with I-beams, and the wood roof decks reflect the wood decks of the old railway bridges. These structures complement recreation areas where this type of construction is present in existing bridges and buildings. Craftsman-style shelters were designed to fit into parks to match that style of architecture present in the homes of the neighborhoods. In addition to providing shelter, structures can also perform specific functions. Athletic fields provide the opportunity for exercise and socialization in a community. Infrastructure provides protection from environmental elements and can also generate revenue. The ancient amphitheaters of Greece and Rome are testament to the fact that the outdoor theatric presentations have been a part of life not only for centuries, but for millennia. Modern stage covers or bandshells continue to be built for outdoor presentations of all kinds. Musical and theatrical performances, public ceremonies, and community meetings are just a few of the uses for bandshells that can be built on flat ground as well as at the base of an amphitheater. The top image shows a bandshell in Campbell Park in Huron, South Dakota. It was constructed in cast concrete and covered with steel roofing, and is an example of early 20th century bandshell design. In contrast, the bottom image is that of a stage cover at Safita Park in San Diego, California, designed by Schmidt Design Group. The park opened in 2017. Cycling has been enjoyed for nearly 200 years. Bike racks, lockers, and storage buildings have changed over the years to meet the ever-growing needs. Shelters can have attached or freestanding bicycle racks with either horizontal or vertical storage, and can be designed with or without wall enclosures. Large free-span structures have been used to house carousels. Hexagons, octagons, decagons, and dodecagons in sizes up to 100 feet in diameter have been designed with an elevated eave height and or a second tier to accommodate the height of the center post of the carousel. Vented or glazed cupolas and clear stories can help let in light and let out heat. Typically, the shelter manufacturer will provide the frame, roof, and cupola. The general contractor will provide the walls, windows, and doors. Clock towers can accommodate a variety of clock sizes. They can be illuminated and provide automatic time control. Many shelters are partially enclosed to house restrooms, concessions, and storage areas. Larger shelters can be enclosed for meeting spaces and community activity centers. Wall systems vary, but the most common method of construction is to erect the shelter and build the walls of the structure underneath the roof. Panelized wall systems are available, as well as timber wall systems that go up in the same way that milled log homes are built. Farmers markets exist in many countries worldwide and offer farmers increased profits over selling to wholesalers, food processors, or large grocery retailers. They reflect the local culture and economy and help to maintain important social ties. Local businesses nearby also benefit from the increased traffic. Many towns and cities erect permanent shelters to house farmers markets, and these structures can also be used for other community activities. Golf courses utilize shade structures for a number of different uses. Large open pavilions are used for outdoor events. Gazebos offer shade or protection from sudden rain out in the fairways, and driving ranges often provide cover from sun or rain. Covered benches with ball washers attached to the columns are used at the tee boxes. Shelters with power outlets are used to protect golf carts from the sun's UV rays while charging the batteries, as seen in the photo here. Mailbox shelters can be fitted with manufactured mail delivery systems for use in residential or commercial developments. Custom structures can be manufactured to the designer's specifications. Kiosks, triosks, and display shelters can be fitted with display cases for outdoor use. The weather-resistant display cases can be a single or double-sided, and the doors can be fitted with full-length hinges and locks. While the season for outdoor classrooms may be shorter in the northern climates than in the southern, this outdoor classroom in Beverly Hills, Michigan gets plenty of use. This outdoor classroom is used for botanical studies. Steel shelters offer more durable, longer lasting, more permanent enclosures than traditional aluminum shelters. Fully or partially enclosed, these shelters can be accessorized with solar powered or direct wired lighting, display cases, infrared heaters, doors, benches, logos, and signage. Steel shelters also provide a durable solution to shading children's play spaces. Enclosures for portable toilets are made by adding wall panels to a small shelter of any kind. The walls can be made of a variety of materials, including recycled plastic planks, tongue and groove wood planks, polycarbonate sheeting, or any kind of mesh or perforated steel screen. Outdoor meeting spaces have been a part of every society throughout recorded human history. In the 6th century, before Common Era, the Agora in Athens was a center of civic activity, and with the rise of democracy became the center of that city's institutions and the heart of civic life. The town square has always been a place of commerce, communication, and camaraderie. And what can be more scenic than an island lake at sunset? Bluffs, mountaintops, oceans, and lakes offer us a chance to appreciate our natural surroundings, and shelters provide a place to take it all in restfully. And some shelters are intended for nothing more than getting off your feet, whether for a momentary pause or a prolonged reading session. Integrated seating can be designed into the shelter. Side panel decorative screens can provide privacy. Electrical outlets can be provided for charging stations, and solar-powered security lighting makes the location safer in the evening hours. Trail systems often need small, inexpensive shelters for waysides. Open campuses utilize walkway covers to protect the public from the elements during inclement weather. While lightweight aluminum walkway covers make up much of the market, more durable steel structures are capable of bearing higher snow loads, like this entrance to a long set of stairs at Syracuse University. And one of the applications of open structures is a space for outdoor dining. Restaurants, vineyards, breweries, zoos, sports complexes, and more often offer outdoor seating. Public fishing areas often provide a location to clean the catch. A small shelter is perfect for covering the fish cleaning station, which protects not only the fishermen, but also the equipment. So, what is pre-engineered? The term pre-engineered means construction of or employing prefabricated modules, according to the Merriam-Webster Dictionary. The pre-engineered concept started back in the early 60s, but didn't really take off until the 1980s with the metal building industry. Initially, pre-engineered buildings were made from off-the-shelf products that had been pre-designed. The information was placed in tables for ease of use by the manufacturer. With the evolution of computers, tabulated design charts are no longer needed. And what are alternatives to pre-engineered? The main alternative to pre-engineered structures are ones that are fabricated in the field from raw stock or site-built. This means that the sections are fabricated or connected in the field, generally utilizing a welded connection, but some site-built shelters can also use bolts. Because the fabricated parts may be totally fabricated in the field, this has the potential to lead to quality issues. Most of the time, a steel fabricator will be hired to provide the parts fabricated to length. The local fabricator is normally charged with developing the fabrication prints for the parts under the review of the structural engineer. These are generally two separate companies. The contractor and the design professional are ultimately responsible for the review and final quality of the products. So if the contract is not specific enough, there could be issues in this area, especially in small shelter designs. Most of the pre-engineered shelter suppliers offer design and engineering capabilities. This design expertise allows for proper proportions and clean lines to be included in the designs, which are not always provided with conventionally framed and site-built structures. This is applicable for standard offerings and, more importantly, for custom designed projects. The design expertise allows manufacturers to provide valuable insight on different applications for shelters and their locations. The design services also help landscape architects to stay in control of shelter designs without having to provide all of the design work themselves. Most manufacturers will work with architects, providing design guidance and sketches for projects, and may provide this at little to no charge, a valuable design service for design professionals and their customers. The design and engineering functions provided by the pre-engineered supplier mean countless design visions can be realized, such as customized column designs in various formats, customized ornamentation for the project site, different roofing styles, modified roof pitches, accessories such as cupolas, column wraps, and high-end powder-coated finish systems. The main advantage that a pre-engineered shelter system has over a site-built shelter is that the structure has been designed as a complete system rather than a combination of parts from several sources that are then fabricated to form a completed structure. The next advantage to using a pre-engineered shelter manufacturer is that they also provide the structural engineering for the created design. The manufacturer will either have an engineer on staff or they will hire an engineering firm to provide the structural engineering required for the specific design, a more expensive option and the only option for site-built structures. Accomplishing this within the confines of the pre-engineered shelter manufacturer's own facility allows them to provide engineering that is not done in a vacuum. This means that the engineering is done in conjunction with the standard manufacturing practices developed for the products, thereby producing a more cost-effective design. In addition, having an in-house engineer speeds up the process. The engineering is normally done to the specific building code requirements for the project's location. In the past, manufacturers would design standards to meet certain loads. Often they had multiple load values for the standards, and then a design would be picked that met the local code requirements. This was an inefficient practice, particularly in the use of the members, as some may have been oversized for the project site. Most pre-engineered shelter manufacturers design to the local governing building code for the size of the shelter that is desired. This is a better use of the steel framing than using pre-designed standards, as you are only paying for the amount required. This method provides a site-specific design for the shelter and its foundation. Early in the pre-engineered shelter story, some manufacturers stocked certain sizes of shelters. Normal sizing was in 4-foot increments, starting at 12 feet. However, sizes in between the 4-foot increments were considered custom, and additional charges were applied. Currently, most pre-engineered shelter manufacturers have highly automated processes and can fabricate a shelter to any size required. It is possible to design, engineer, and fabricate whatever the budget will allow. Shelter design is generally considered a standard offering, with many options available for customization, such as column styles and ornamentation. But since everything is engineered and made to order, all items have become standard. With the engineering and design fulfilled by the shelter manufacturer, the fit and finish of the shelters is superior to site-built shelters. The manufacturing process itself is where the pre-engineered shelter manufacturer excels beyond what a local fabricator or site builder can achieve. In a site-built situation, the fabricated parts could be done in the field or could be subbed out to a local fabricator who will cut and drill the parts to the fabrication prints provided. The pre-engineered shelter manufacturer is expert in fabricating the parts for the shelters, having developed and honed techniques for cutting, drilling, and welding the shelter parts in a specialized fabrication facility. A pre-engineered shelter manufacturer should offer precision equipment, automated, computer numerical control to provide the best quality in the shortest amount of time. They should offer a controlled factory manufacturing process and an on-site construction process that follow OSHA requirements for safety, and they offer certified welders. Pre-engineered shelter manufacturers can provide a high-end factory-applied powder coat finish. Powder coating is a superior finish that cannot be applied in the field and performs better than any site-applied wet coat finish. Manufacturers may provide corrosion protection through the use of primers applied to clean steel. Some use zinc-rich primers and some use an epoxy eco primer, the latter of which is similar to what auto manufacturers use on vehicles. The final color, in the form of a TGIC, curing agent, triglycidyl isocyanurate polyester powder coating, is applied over the primer. The coating is electrostatically applied and then cured onto the steel. A 4 to 6 mils powder coating is typical, with some manufacturers providing a coating thickness of 8 to 12 mils. Mil thickness is a common measurement in manufacturing. A mil is a unit of thickness equal to 1/1000th of an inch. With regard to installation, there's a big difference between the installation of pre-engineered and site-built structures. Most pre-engineered shelter manufacturers deliver the products banded together for easy shipment to the job site utilizing flatbed truck shipping. All pre-engineered structures utilize bolted connections for the main framing connections. This allows for ease of installation and straight connections. There is no field welding. All connection plates are fabricated in a quality-controlled factory setting, resulting in great precision in the locations of the holes. The bolted connections and pre-aligned holes afford the relatively quick installation of the structural framing. The connections are normally welded for site-built shelters, which requires hiring welders that will have to work up on a lift. This usually means higher welding costs than those for a factory setting. Quick structural framing installation means more time can be spent on the areas that require more finish work, the roofing and the trim. Manufacturers often provide pre-cut metal roof panels for shelter styles that have hip roofs. This again saves time in the field. The installation crew can install the panels without having to measure and cut them beforehand. These factors combined allow the designer and their clients the ability to customize structures to meet specific needs without exceeding the budget, regardless of the size of the shelter. Some examples are shown here. So you see colored plexiglass, you see fabric and wood and steel combined, curved members, and all kinds of different settings. And here are some other custom design projects by shelter manufacturers. As depicted here, the pre-engineered process offers a variety of advantages over the site-built process. Pre-engineered shelters and other outdoor recreational structures have evolved significantly over the years. Landscape architects, city planners, and park designers have a vast palette of choices when it comes to selecting outdoor recreational structures for their landscape designs. Design is how you create a structure that is pleasing to the eye, and engineering makes sure it passes the building code. Without both, the shelter could either be safe and ugly or beautiful and dangerous. Work with a manufacturer who blends design and engineering to create shelters with structural integrity that are pleasing to the eye. And here's our first review question. What is the main advantage that a pre-engineered shelter system has over a site-built shelter? The answer for that: the main advantage is that the pre-engineered shelter structure has been designed as a complete system rather than a combination of parts from several sources that are then fabricated to form a completed structure. Now we'll discuss some of the many elements to consider when designing and engineering a shelter. There are aspects of good visual design that can be considered relative. Beauty is in the eye of the beholder, after all. Yet there are specific means by which an artist organizes a work of art. And we have those shown here. The pattern or repetition is the regular arrangement of repeated shapes. Contrast is the juxtaposition of alternating textures or values to highlight their differences. Emphasis is a design element that becomes a focal point. Balance is the arrangement of elements to create the impression of equality in visual weight. Proportion is the relation between elements with respect to size and quantity. Harmony is the sense that all elements form a coherent whole. And rhythm or movement is the systematic arrangement of elements that drive the eye to the focal point. These principles of design also come into play when creating an aesthetically pleasing shelter designed to achieve the desired intent, which in most cases is to invite people in. Proportion and balance. The two elements illustrated in these photographs are proportion and balance. In the photo on the left, the overhang on the upper tier is longer than the overhang on the lower tier, giving the shelter a top-heavy look. Also, the visual weight of the roof tier seems to demand larger columns with enough visual weight to carry them. The shelter in the photo on the right demonstrates the correct use of both of those design elements. Attention to detail is important not only in the design of the shelter, but also in the fabrication of its parts and the care taken during its construction. Fit and finish are important in the overall aesthetic appeal of a structure. Good design includes engineered connections that achieve the overall aesthetic and the required structural integrity. Skilled fabricators know how to produce parts that fit together tightly to form a unified structure. Trained and licensed contractors are required to install the structure according to the manufacturer's installation instructions. Attention to detail is required from concept to installation to produce a durable and attractive structure that will provide service for decades. There are many options and accessories available to consider. For example, industry standard shelters are available in multiple roof tier configurations. Depending on the manufacturer, 2 tiers are usually available on all shelters, while 3 tiers are available on shelters over 40 feet. The photos show the difference between a vented roof option, which is the top photo, and a clear story roof option. The clear story room option offers the room to install ornamental rails, louvered vents, or windows. Check the manufacturer's offerings for standard and custom designs for options and accessories, such as those pictured, columns and ornamentation, as we discussed earlier. Cupolas are available in a wide range of standard sizes and styles. Manufacturers may also offer custom sizes and styles. Weather vanes can be used to adorn the peak of a cupola and should be available in both standard and custom options. A standard base connection for shelters is to bury the base plate 6 inches below finished concrete. Manufacturers may also offer a surface mounting option with or without base covers, and those are illustrated in these two drawings. The left is a buried base plate on top of the footing with the concrete slab poured around it, and on the right is the surface mounted column base plate with a cover over the bolts. Most pre-engineered shelter manufacturers have a standard shelter offering, usually including some version of a square, hexagon, octagon, rectangular gable, rectangular hip, and curved roof rectangles. Other standard products may include gazebo designs, pergolas, mini shelters, and kiosks. Typically offered in 4 or 6 foot increments with a standard roof pitch, they can now be ordered in 1 foot increments without incurring custom design charges. Options and accessories, as discussed, can be added to modify the shelter's appearance and function. Eave heights and roof pitches can be raised or lowered to suit the design intent. Benches and wall panels can be added to the frame as required. Manufacturers may offer some type of finish modification, a solar lighting package, or lightning protection. One of the questions most often addressed to manufacturers is, do you do custom buildings? Producing custom shelters and other structures requires a certain level of expertise not held by all manufacturers. Be sure to inquire about those capabilities if you approach a manufacturer with a design not found in their product offering. Often with custom structure design, it is best to involve the manufacturer's design and engineering personnel in the early stages of design in order to achieve the greatest cost savings. Shown here is the multicolored roof on the Credit View Activity Hub, comprised of layered translucent polycarbonate in a variety of hues. The roof is an interesting mosaic that provides colorful light projections to the pavement below. A standard roof option is 24 gauge Galvalume roof panels with a PVDF resin coating, such as Kynar 500. Ribbed panels can be pre-cut by the manufacturer and may require minor field adjustments for proper fit. Standing seam roofing is another option and may be supplied uncut to be cut in the field by the installer. Matching trim and 26 gauge Galvalume and fasteners may also be provided by the manufacturer. The middle photograph shows a structural insulated panel roof, which is a high-performance building system. The panels consist of an insulating foam core sandwiched between 2 structural facings, typically oriented strand board on the roof side and some form of T111 fir plywood on the underside. And on the right, 2x6 and 2x8 tongue and groove decking are also used, with the most common species being southern yellow pine, western red cedar, and western lodgepole pine. Shelters with structural insulated panel or tongue and groove roof decks require finished roofing materials. While this can be any roofing material available to the building trades, most manufacturers offer pre-cut painted metal, steel, or aluminum roofing panels in a variety of rolled configurations, such as ribbed panel, corrugated, standing seam, and others. Also offered are shingle packages in fiberglass or sawn cedar, as well as tile roofing in a variety of styles. For steel finishes, you can get prime painted finishes that are factory priming that protects the steel components from corrosion throughout the shipping and erection process. The steel is cleaned to remove loose mill scale, loose rust, loose paint, and other loose detrimental foreign matter. The clean steel will then be prime painted with a quick dry, lead and chromate-free alkyd primer. Finish painting in the field is required. For hot dip galvanized finishes, the process produces a zinc coating on steel products by immersion of the material in a bath of molten zinc metal. The steel to be coated is first cleaned to remove all oils, greases, soils, mill scale, and rust. Because galvanized steel requires no maintenance for decades, its use in public construction is an efficient use of public funds. The E-coat and powder coat finish is a premier steel coating and is a combination of liquid epoxy primer and 2 coats of TGIC polyester powder coating. The process has 5 steps. First, the steel is shot blasted to the specification of SSPC SP10, shot blasted to near white condition, removing all oil residue, mill scale, weld spatter, and slag. The steel is then immersed in zinc phosphate in an 8-stage pretreatment process. Then it is immersed in an electrostatically applied liquid epoxy and coated to a uniform 0.7 to 0.9 mils. This E-coat totally encapsulates the part, preventing rust. Following that, a double coat of TGIC polyester powder is applied, 1 coat of color, and 1 clear coating for a final finish that is 8 to 12 mils thick. Finally, all materials are inspected to meet 100% coating, popper cure, film thickness, and impact resistance. In highly corrosive environments such as coastal areas, a high-dipped zinc galvanizing prior to applying a finish coat is recommended. This may produce a slightly rougher finish once coated, but will provide added protection against corrosion. And under engineering considerations, design must meet the local building code requirements where the shelter will be installed. There are a number of building design loads to consider. Dead load is the total weight of the structure's installed components. Collateral load is additional dead load that is applied to the structure that is accounting for additional items that will be attached to the structure, such as sprinklers and lighting. This is in addition to the dead load. Live load is the minimum downward acting load that a shelter must be designed for per the local building codes, 20 pounds per square foot. Ground snow load is the amount of snow that will accumulate on the ground and specified by the local building department or ground snow load maps for the area. This is used to determine the roof snow load, which is the downward acting force on the shelter's roof determined by a percentage of the ground snow load that will accumulate on the roof. Wind loads include both lateral and uplift load. Lateral or racking load, which is the horizontal load that pushes and pulls on the structure based on the wind's direction, and uplift load, which is created when wind flows over the roof and under the roof on an open structure. The flowing over the roof creates suction or uplift on the roof. The flowing under the roof creates upward pressure on the bottom of the roof. Essentially, open shelters are like large airplane wings. And then you have the seismic load, which is the horizontal force applied to the structure during a seismic event. All connections used in the structure are designed to be bolted together using high-strength A325 bolts. Connections are made in such a manner that the bolts cannot be seen once the connection is fully tightened. A permit is required from the local building department before installation of the foundation, and the subsequent installation of the structure itself can begin. The permit is granted once the engineering calculations and drawing for the structure are reviewed and are approved by the building department. Our second review question: what type of finish is recommended for highly corrosive environments? You can hear the dun, dun, dun in the back. In highly corrosive environments such as coastal areas, a hot-dipped zinc galvanizing prior to applying a final finish is recommended. This may produce a slightly rougher finish once coated, but will provide added protection against corrosion. And now we'll look at how the design process works. In the initial consultation, you will research shelter products and manufacturers and formulate a design concept. The architect designer can meet with a shelter manufacturer or may even be able to submit an online quote request. The manufacturer will typically require information such as the project name, the project location by zip code, shelter information, which is the minimum information needed, style, size, roof type, roof pitch, and any additional information such as drawings, specs, sketches, custom components. A quote can be given if an existing design meets the project design criteria. If no design exists, that meets all the criteria, the manufacturer will perform calculations based on criteria and create the design. They will create a preliminary drawing, develop a material takeoff list of materials with quantities and types such as specific grades of steel that are required to build a design structure or item, and they will create a preliminary footing design. Preliminary engineering involves reviewing the building information, searching for design loads based on zip code, creating a wireframe, selecting member sizes and anchor layout, and sending to detailers for drawings. Once engineering, drawing, material takeoff, and footing design have been completed, a quote can be supplied. If revisions are required, the process repeated until the design is approved and the final quote is given. Why is that not changing? Oh, okay. Final engineering comes typically when there's an order, and that involves retrieving the building design loads from the governing local entity, creating the model, selecting member sizes and design connections, reviewing soils report if provided and design footings, and then sending back to the detailers. A 3D model of the shelter is created and used to formulate a submittal package with design information, foundation detail, member and bolt sizes, and connection details for the frame and roofing. Typically, a review is done by another detailer, and a final review is done by the engineer. The submittal package is then sent for approval. Manufacturers can give out ballpark budget numbers for the preliminary phase of project costing. These numbers reflect a range of possibilities for a proposed structure. Most of these budget numbers are derived from historical job costing on projects with similar shelters. A firm quote is based on the finished specification and design. It is generated from information on materials and labor to produce a specific structure to meet the building design loads for the geographical location of the project. Manufacturers typically provide some form of specification that can be used in the bid documents for a new project. One of the most widely used specification systems in the US and Canada is Master Format, published by Construction Specifications Institute, or CSI, and Construction Specifications Canada, CSC. Once the submittal is approved and the fabrication process begins, it will take about 8 to 10 weeks. Anchor bolts can often be shipped within 1 week after fabrication approval is received. For fabrication print development, a 3D model is used to create fabrication submittal prints for approval. And once the submittals are approved, the model is used to create individual part prints for each subassembly part included in the model. The fabricator will detail tube, plate, and fastener sizes, create roof and trim kits, and count fasteners for both the frame and roofing. A bill of materials is created and a final review is performed before releasing the print to fabrication. The fabricator will perform material takeoffs, create a cut list, check inventory for stock, send order lists to purchasing, and schedule each step of the manufacturing process with assigned completion dates. For frame finishing, steel frame components are finished according to the order, E-coated, powder coated, prime painted, or galvanized, which takes about 10 working days. Once the frame components are finished, a shipping date is arranged, the materials are delivered to the job site, and installation can begin. Most manufacturers' representatives are either licensed contractors themselves or work regularly with one or more contractors who can perform the installation of a shelter structure. Specifications normally state that the installer is to be experienced in the building trades. They can include excavation, concrete foundation and flat work, steel or wood frame erection, carpentry, roofing, masonry, and sheet metal work. Construction timelines vary from project to project. Typically, a 30-foot shelter can be erected on finished footings by a 3-person crew in less than a week. So how can shelters fit into green design practices? Design and construction practices that significantly reduce or eliminate the negative impact of buildings on the environment and building occupants are called green or sustainable design. Loosely defined, green building is a collection of land use, building design, and construction strategies designed to protect the environment, reduce energy consumption, and promote occupant health. The goal of sustainable design is the development of high-performance buildings that improve local and global communities. Shelters can contribute to the sustainable design objectives of a landscape project. The following slides outline their potential contributions to projects seeking LEED certification. Manufacturers, The intent of the Heat Island Reduction Credit is to minimize effects on microclimates and human and wildlife habitats by reducing heat islands. Under option 1, non-roof and roof, the requirements are to provide shade with architectural devices or structures that have a 3-year aged solar reflectance value of at least 0.28 or with an initial solar reflectance value of at least 0.33 at installation. They must provide shade with structures covered by energy generation systems and provide shade with vegetated structures. Solar reflectance is the measure of the amount of solar energy that is immediately reflected from the surface. Reflectance is reported as a decimal or a percentage. A cool metal roof with a high solar reflectance and high thermal emittance will have a lower surface temperature. The energy that is not reflected is absorbed by the roof panel as heat and then removed by airflow over the roof or re-emitted into the night sky as infrared energy. The re-emitted energy is the thermal emittance, which is also expressed as a decimal or percentage. By using cool metal roof, the heat island effect is reduced, which minimizes the impact on microclimate and human and wildlife habitat. Shelters are available that have metal roofing that meets the solar reflectance index criteria for LEED and for the Energy Star Certified Roof Products Program. Shelters are also available with vegetated roofing. The intent of the Renewable Energy Production Credit is to reduce the environmental and economic harms associated with fossil fuel energy by increasing self-supply of renewable energy. It requires the use of renewable energy systems to offset building energy costs. Shelter roofing materials can have integrated solar panels for energy production. The intent of the Building Product Disclosure and Optimization Sourcing of Raw Materials Credit is to encourage the use of products and materials for which the life cycle information is available and that have environmentally, economically, and socially preferable life cycle impacts. To reward project teams for selecting products verified to have been extracted or sourced in a responsible manner. Under option 1, leadership extraction practices, Wood products must be certified by the Forest Stewardship Council or USGBC approved equivalent. Recycled content is the sum of post-consumer recycled content plus 1/2 the pre-consumer recycled content based on cost. Wood shelter products can be supplied with FSC certification. Steel is the world's most recycled material. The primary steel frames for a shelter can be made from recycled scrap generated from both consumer and industrial users. On a weighted average, this accounts for roughly half of the steel used in a typical shelter. The intent of the Building Product Disclosure and Optimization Environmental Product Declarations credit is to encourage the use of products and materials for which life cycle information is available and that have environmentally, economically, and socially preferable life cycle impacts. The requirement is to achieve one or more of the options. Option 1, environmental product declaration, and option 2, multiple attribute optimization. Most of today's metal cladding products carry a 25-year warranty and require minimal maintenance to last much longer. Properly protected primary and secondary framing members can last indefinitely. This compares exceptionally well with other building materials. Steel is naturally termite and rodent resistant and requires no pesticides or treatment for protection. Shelters can be relocated and reused, making them adaptable to different end uses and extending their usable life. Steel from buildings can also be 100% recycled and used for new buildings or in a variety of other uses. There are many industry-wide EPDs available that summarize the results of steel life cycle assessments. The intent of the Construction and Demolition Waste Management Credit is to reduce construction and demolition waste disposed of in landfills and incineration facilities by recovering, reusing, and recycling materials. The requirement is to recycle and/or salvage non-hazardous construction and demolition materials. Calculations can be by weight or volume, but must be consistent throughout. There are 2 paths under option 1, diversion. Path 1, divert at least 50% of the total construction and demolition material. Diverted materials must include at least 3 material streams. Path 2, divert at least 75% of the total construction and demolition material. Diverted materials must include at least 4 material systems. Scrap material from shelter construction, as well as the packaging materials, can all be recycled. The intent of the Environmental Tobacco Smoke Control Credit is to prevent or minimize exposure of building occupants, indoor surfaces, and ventilation air distribution systems to environmental tobacco smoke. The requirements are to prohibit smoking outside the building except in designated smoking areas, located at least 25 feet from all entries, outdoor air intakes, and operable windows, and to prohibit smoking outside the property line in spaces used for business purposes. There are 2 options. Option 1, no smoking, and option 2, compartmentalization of smoking areas. Shelters provide a designated outdoor area where the building occupants and visitors can go to smoke. In our last review question, how can shelters contribute to the LEED Sustainable Sites Heat Island Reduction Credit? And the answer is by using cool metal roofing or cool roofs, the heat island effect is reduced, which minimizes the impact on microclimate and human and wildlife habitat. Shelters are available that have metal roofing that meets the Solar Reflectance Index criteria for LEED and for the Energy Star Certified Roof Products program. Shelters are also available with vegetated roofing. And so we'll conclude with a few project profiles. This project was initiated by the Rotary Club of Windsor 1918 in a request to the city of Windsor to help celebrate their 100th anniversary of service in that city. In August of 2016, the city of Windsor approved the intent for a plaza with sitting areas to provide shade for users of the Windsor Riverwalk at the Civic Terrace. The circular layout of the structure emulates the rotary wheel as deconstructed and reconstructed to symbolize the future of the Rotary organization. The trellis lies on the axis of the Civic Esplanade from City Hall at the south to the Detroit River. Looking up at the roof panels, one is reminded of Vincent van Gogh's painting, Starry Night. The roof panels are misaligned to indicate the future is never a predictable entity. To lighten the structure, the columns were designed to arc outward to make the plaza space feel more open to the air. About the columns, the project designer Stefan Fidjuk said, "In honor of the First Nations who settled along the Bending River, today known as the Detroit River, the backsides of the columns form a series of tridents to symbolize the Ojibwe, Ottawa, and Potawatomi, who make up the people of the Three Fires. At night, the tridents are illuminated from the base to further appear like fires, burning as a symbol of the people of the Three Fires." At Columbus Park in Piscataway Township, New Jersey, they got a facelift by township landscape architect Henry Hinterstein. This wonderful combination of landscape and hardscape elements includes a 24-foot by 28-foot shelter that covers a portable restroom trailer during the summer months. Also, two 6-foot by 16-foot trellis structures, an entry arch customized with the park name and the township seal, and two 12-foot octagonal gazebos on the fishing docks. Hinterstein successfully mixed design features throughout. The large shelter, the arbors, and the entry arch utilize craftsman-style columns. The shelter has retro industrial style cross bracing in the gable ends, supported by the township emblem. The entry arch also has an emblem mounted on steel lattice above the park name. The fishing dock shelters have stepped columns and handrails. All the shelters have medium bronze standing seam roofing. And our final project, in 2015, the city of Aurora, Illinois, demolished a high school that had been built in 1905. They planted grass in the open space and deeded the property to the Fox Valley Park District in 2016. In the summer of 2017, construction of the new Black Hawk Park commenced on the old school property. The park was designed by Todd Stanton of Design Perspectives, Inc. of Naperville, Illinois. In keeping with the wishes of the Park District's planners, one of the park's new amenities was a 22-foot by 30-foot curved roof shelter, which was intended as a throwback to the original school design, which you can see in the upper right-hand. Says the landscape architect who sketched the concept, the custom roof line of the shelter was inspired by the unique elevation of the old school that once graced the site. The design of the shelter was directly tied into the historic cues of the old school with the center keystone feature and decorative scroll accent end pieces. The shelter pillar bases were built by local masons using reclaimed brick salvaged from the old school that further enhanced the historic value of the overall design. The collaboration between the Park District planners, consulting landscape architects, and the manufacturer designers created a focal point for the new park based on a piece of history truly special to the residents of Aurora. And so that is the end of our presentation. And I saw Sean taking a lot of notes. So I guess, Lauren, if you want to take back over.
Thank you so much, Richard. That was wonderful.
Oh,
Does anybody, if anybody has any questions, we're going to give you all a minute to type them into the chat box or into the Q&A box. Right now, we don't have any open questions. Wait for a second, and I'm going to go ahead and share my screen.
Ah, there we go.
All right, looks like we have not a question, but a comment from Joseph Schneider. Enjoyed the web. Thanks for all the hard work putting these together. You are so welcome, and I'm very glad this was helpful for you. Does anybody have any questions for Richard? All right, I'm going to give you guys a couple more minutes, and if you are typing in questions, go ahead and keep doing that. I'm going to highlight some of the upcoming opportunities we have. We have another few webinars coming up. June 16th, we have one on expansion joint covers and fire barriers, which is going to be an HSW credit. And on June 19th and 26th, we have the next two installments in our Storytelling with Architects series. We have Zach Smith, who is an AIA New Orleans member, and Kathleen Gordon, who is the executive director of the AIA Louisiana state chapter. We're very excited about those, and we hope you will join us. And it looks like there are no other questions. So here are some other resources for y'all. We have a LinkedIn members forum. Feel free to join, continue the conversation. We have COVID-19 resources on our website. You can find links to register for all of the webinars I just highlighted at our website, aianeworleans.org. And of course, you can always email me, Lauren, or our interim executive director, Erin. All right, thank you again, Richard, and I hope that y'all have a great day.
Thank you, Lauren.
Take care.
Okay.